So we're going to review some key features of our quadratics that we covered in Chapter 10. We're also going to be looking at and reviewing how to do completing the square. We went over completing the square. We didn't use it a whole lot in Chapter 10, but I told you we were going to come back around and we're going to have to use it a lot in this chapter, which is why we did it then. And then what we're going to do is add in a new type of parabola, a horizontal one instead of a vertical one like we've seen. And we'll go into the more formal definition of a parabola, which focuses on the geometrics with what we call a directrix as well as a focus. A lot of the skills that we're using here are going to transfer into the content in Chapter 13 we call our conic sections. So this should look familiar from the Chapter 10 notes. I just kind of copied it over. We have our basic quadratic graph, which forms the parabolic shape. We call that graph a parabola. Some of the most important parts that we're going to need to identify being the vertex, which is that minimum point, or if our parabola opens down, that's our maximum point. And then we have the axis of symmetry, which is that imaginary vertical line that runs through the vertex. That axis of symmetry has that symmetry, that mirror image on both sides. So if we know one point on one side of our axis of symmetry, then we can use that relationship to find its mirror image point on the other side. We're going to be using that relationship with our horizontal parabolas, making it a lot easier to graph those. So we first want to make sure we can identify where's our vertex, and then by association, the axis of symmetry. Okay? The next thing we'll go over is we have a couple different equations for our functions. So this first one here, our quadratic formula, some people call it standard form. The nomenclature for it's kind of vague. It's for our sense of the word, we're going to call it general form. Okay. There's a couple different ways that we can write quadratic functions, but this is the first way that they've been introduced. Also, instead of f of x, you could have y. Same idea. That's our general form of a quadratic. The name isn't so important, except for when they ask for it in a specific form, but usually there's different options. It's not that big a deal. Rarely do we want it in general form. Usually we're taking it from general form and rewriting it in some other way so that we can graph the equation. One of the ways that we can graph it is when we have it in vertex form. Okay? This is actually one vertex form. A lot of people call this standard form. It's kind of stupid the way they name it. It is what it is. But this is something that I refer to as vertex form because it makes it very easy to identify the vertex. Okay, so we can rewrite the equation in this form. Again, if we want to use y instead of f of x, we have y equals ax minus h squared plus k. H and k are the values of our vertex. Whatever the h value is, that's the x value of the vertex. Whatever k is, that's the y value of the vertex. And then our axis of symmetry is given by that vertical line, x equals h. If our leading coefficient, that a value is positive, our parabola opens up. If the a value is negative, the parabola opens down. So up if a is positive, or down if a is negative. Depending on the value of a, that makes our graph wider or narrower. We're not going to focus so much on that part. We're going to be looking at a different feature later on. Okay? So that's our vertex form. How we get here from standard form is by completing the square. So that's where that comes back in. So what we're going to do is we're going to look at this parabola that's in general form, and we're going to complete the square to rewrite it in vertex form. That process is going to change just a little bit from the first time we did it. The first time we did complete the square, we ignored the f of x and we just focused on the three terms. But we need to keep that f of x with that y value when we're rewriting the equation. So we're going to rewrite it to have y instead of f of x. It just makes it a little bit easier when we're working through it. And what we have to do is we need to isolate those two terms and then add something so that we end up with a perfect square trinomial. That's the fundamental reason for completing the square. Because if we have a perfect square trinomial, it always factors to be a binomial squared, and we can get it to look like this. That's what we're trying to have, is to get that binomial squared as part of our factors. Okay, so we need that perfect square trinomial. So the first thing we need to do is we need to move that -9 to the other side of the equation. How do I move that -9? We're going to add it. So we have y plus 9 equals x squared plus 4x. Okay? Now, I'm going to flip those just to make it a little bit more consistent with what we've done in the past. Okay? That's all I did. I just flipped them. All right? But we want to leave this gap because now we need to make a perfect square trinomial. We're going to put these boxes in. So we need to add some number that turns this left side into a perfect square trinomial. Does anyone remember what formula we used to find the number that goes in that box? Good. So b over 2 squared will tell us what number needs to go in that box. What's my b value for this equation? 4. So 4 over 2 squared. 4 over 2 is 2. And then 2 squared, 4. Okay? So 4 goes in the box on both sides. 4 goes in the box on both sides. Now, before we squared it, we had this 2. Don't forget about that 2. That 2 is going to come back around. So now this is going to factor into a binomial squared. The key is it's going to be x and then what? Is it going to be plus or minus? Plus, because that is plus. So we're going to keep that plus sign. If that was minus, it would be minus. X plus what? 2. That's where that 2 comes back around. X plus 2. So x squared plus 4x plus 4 factors to be x plus 2. Let me get rid of this so we don't think it's division. Okay? Factors to be here. And on the right side we simplify. Y plus 9 plus 4 simplifies to be y plus what? 13. Okay? So we completed the square to get a perfect square trinomial so we can factor to the binomial squared. Now we just need to get y by itself in order to finish getting in vertex form. So what can I do to isolate y? Subtract 13. So we subtract our 13 from both sides. So we end up with x plus 2 squared minus 13 equals y. And if we want to flip it around, we can. X plus 2 squared minus 13. So y equals x plus 2 squared minus 13. So that is our vertex form. Okay? That's our vertex form. At least the one that we're going to be dealing with for now. Compare that to our formula. F of x equals ax minus h squared plus k. That's our formula. All right? We're going to compare it. Remember that our vertex is h and k. Our vertex is h and k. What is the h value of that quadratic? -2. Sign switch. Negative h is -2, so h is -2. What's the k value? 13. So our vertex is the point -2, -13. Vertex is -2, -13. Okay? So it's the more time-consuming way to find the vertex, but it's what we need as we move into more complex conic sections. We have to be able to complete the square. When we're dealing with circles, we complete the square to find the center or the center of an ellipsis. We also use it to find the center of a hyperbola. Okay, when we get to that, so that completing the square is a process that we continue as we move complicated relations. Now for funsies, what would my axis of symmetry be? Based on the vertex, what's the axis of symmetry going to be? Close, you're missing part of it. Negative 2 is the number. X equals negative 2. X equals negative 2. Because it's a vertical line. A vertical line is x equals, and then whatever that x value of the vertex is. It's always the x value of the vertex for a vertical line of symmetry. Okay? So there's our completing the square. Do it again. Slightly different. First two steps will be the same. The second step, we'll add something in, and then pretty much continue like normal. Let's just rewrite it so it's a little bit easier. Change f of x to y and just switch it to the other side. Okay, that's all I did. Took that quadratic, set it equal to y. Alright, what's the first thing I need to move? Subtract 1. Good. So I'll move 1. And let's go ahead and put in our boxes. Alright, now this is where something is, we're going to add in a step here. How do I remove the 2?
Oh, you got to do divide.
Similar idea,
Square root.
wrong. Factor it out. What are we going to do on the other side? There we go. We're going to factor the 2 out of this. So, yes, we're dividing, but we don't want to get rid of the 2. So we're going to factor out the 2, divide each term by 2. Well, since I can't really divide that term by 2, in order to keep it balanced, we need to multiply the box on the right by 2. The box on the right will be multiplied by 2 so that that equation is going to stay balanced on both sides. Then we can go and figure out what's going to be in this box. So we've got b over 2 squared, that's our formula. What's our b value now? 2. Negative 2 is our new b value. So negative 2 over 2 squared, negative 1 squared. What's negative 1 squared? 1. 1 is what goes in the box. So now we can factor. Keep the 2. It doesn't go away. All right. In parentheses, what will my factor be? Minus 1. See how we had a negative 1 here before we squared it? X minus 1. The right side. 2 times 1 plus negative 1 gives me 1. Okay? Oh, I forgot my square. There we go. And last but not least, isolate y. So y equals 2x minus 1 squared minus 1. So what's our vertex going to be? What's the h value of the vertex? Good. It's 1. Sign switch. So h is 1. What's k? Negative 1. So there's our vertex. 1, negative 1. Okay, so if we have that leading coefficient, we have to add in this extra step up here. Okay, but everything else will be the same. The rest of the process will be the same. Questions on that so far? So when you look here and we compare it to our formula, I have x minus 1 and I have x minus h. Those have to be the same. Negative 1 is equal to negative h. Well, if I get rid of the negative, I divide everything by negative 1 to isolate h. I'm just left with positive ones. So on that inside, there's always going to be a sign switch because we have that negative in the formula. Yes. Sure. Go for it. Leave this. Okay. So now let's extend it. It's going to be a lot of completing the square. So now we're looking at parabolas with a horizontal axis. All of our parabolas so far have had that vertical axis of symmetry, and they've opened up or opened down. Well, now we're looking at a horizontal axis of symmetry, which goes side to side. So that symmetry means I either have a parabola that opens to the right, or we're going to have a parabola that opens to the left. Notice the difference. Our vertical ones, we had y equals ax squared plus bx plus c. Our x's and our y's have switched. We're switching all the x's and the y's, and that's what turns the parabola sideways. Same thing if we're looking at vertex form. Compare it to y equals ax minus h squared plus k. We've also switched the h and the k. H is the x value of the vertex. So if I'm switching the h, the x, I have to switch the h, same with the k. So y and k go together, x and h go together. So we're switching those when we're going to a horizontal axis versus a vertical axis. Okay? So the equations are very similar. If you look on the whiteboard there, you'll see all the different forms with the vertical and then the horizontal axis of symmetries on all of those parabolas. They're very, very similar. It's just the x and the y values are changed. The x and the y values are switched. Just the vertex will still be the same, h and k as the vertex. We're not switching those. We just look at a different part of the equation. This gives us the x value. This gives us the y value. Okay? So we're looking at part of the equation for the x and the y because we've changed their location. Instead of x equals a number for our axis, since it's a horizontal line, now we have y equals a number. Y equals whatever the y value is. So it's a lot of the same concept, just switching all the x and y's. If our leading coefficient is positive, then it opens to the right. If our leading coefficient is negative, then it's going to open to the left. Similar to positive opens up, or positive or negative opens down. Now we're just doing left and right. So when we're looking at the formula and we want to identify some of these key features, it's the same idea, but we're just switching the x and y's location and then having to readjust it for our ordered pair. So if we have our formula, x equals a y minus k squared plus h, we can look at our formula and identify the vertex. What is the x value of the vertex with this parabola? Negative what? Negative 4, right? Because there's our h. H is negative 4. Our vertex is h and k. So we'll start with negative 4. And then what's the k value? Negative 1. So our vertex is at negative 4, negative 1. We can go ahead and plot that point to start. We look at our leading coefficient to try and figure out if it's what direction it's going to open. Since it's y squared, we know it's going to be horizontal. It's going to open left or right. So looking at the leading coefficient, is it positive or negative? Positive. So what direction do we go when we're positive? To the right. So we're going to open to the right. That's just helpful for us to know our parabola is going the right way, that we've graphed it correctly. So we know where the vertex is. We know what direction it's going to open. Now we want to look at the axis of symmetry. It's going to be that horizontal line, y equals. Well, what line is our y equals going to be on? Negative 1. Use the vertex. Y equals negative 1. So we'll draw this imaginary line that goes straight through negative 1. So any point that we find above that line will have a mirror image point below the line, and vice versa. So when we're trying to find additional points, what we can do is pick y values on one side, plug those into our equation, get the x value, and then use that symmetry to get the additional points on the other side. So what we can do is start with y equals 0. We'll just go 1 above our axis of symmetry. Okay, y is negative 1. I know where my vertex is. So what about when y is 0? If I go 1 above it, take 0. Let's plug it in. Solve for it. So if I have 0 plus 1 squared minus 4. What's 0 plus 1? 1 squared. 1 minus 4. Negative 3. Now be really careful because we kind of flipped our x and y chart. So when we're looking at our ordered pair, we need to kind of flip it back. The x value is negative 3. The y value is 0. So we have the point negative 3, 0. Now looking at that, we can get some symmetry. So on the other side of the line, what's another point that is symmetrical to the one we already have? Negative 3, negative 2. We can get this right here. Negative 3. And we don't have to plug that in to solve it. We can just use that symmetry to get a third point. Let's do it one more time. But now go up one more. So what's the next y value I can use? 1. So we'll plug it in. 1 plus 1 squared minus 4. Put that there. 1 plus 1 squared minus 4, 0. So what's my ordered pair going to be? 0, comma 1. 0, comma 1. So we can plot that point. 0, comma 1. What's a symmetrical point to 0, 1 going to be? Yep, 0, negative 3. Be symmetrical. Once we got 5 points, we've got enough. Our parabola. Did it open the correct direction? Yeah. We said it was going to open to the right. All of our points continue to move to the right. So we know it opened the right way.
Does it matter that you skip the box?
So I didn't have to calculate these because I got this point by using symmetry, which is why I didn't write it in the box. I calculated this point. I used symmetry to get the next one. I calculated this point and I used symmetry to get the next one. So I didn't need to do it. Domain. What does the domain refer to? The y. The x. It's all the x values. Domain is all my x values. So looking at my graph, what is the least possible x value that my relation could have? Negative. That's the furthest left that it goes. That's the first x value. The lowest x value in that domain. Negative 4. Now, what's the highest x value? It's forever. Never stops. It's forever. So it starts at negative 4, goes towards infinity. Domain is x values. What is range? Y values. What's the lowest possible y value? Lower. Infinity. That line keeps going down. What's the other end? Positive infinity, because it keeps going up. Side note, when we had vertical parabolas, these two were switched. Our vertical parabolas have a domain of all real numbers, but they have a range that is the k value to infinity or switched around. The domain and range are going to be switched. We switch the x and y, so the way that the domain looks and the way that the range looks is also going to switch. The location of h and k is going to switch. Everything is switching as far as x and y goes. And so since we're turning it on its side, my domain's not all real numbers anymore because it starts right here. It doesn't go any further left. So we have to have that bracket on that starting point and go to infinity. If we flip it around the other way, well, that's going to go negative infinity to whatever that h value is, so that pattern is switching. Now this one isn't in vertex form, it's in general form. So we have to get it into vertex form. What's the process that we use to go from general to vertex? What's the thing we've done like 3 times today? Completing the square gets us into vertex form. Now I have this leading coefficient that's negative, just to make it a little bit easier. You could minus 5, but then you're going to have to factor out that negative 1. I'm just going to go ahead and add y squared and subtract 2y to move it to the other side, and then subtract x to move that to the other side. Makes it just a little bit easier. It's not that big a deal, but it makes it so we don't have to do this extra factoring step. If I could erase that without. Move the negative y squared to the side, move the 2y to the other side, move the x to the other side. So that way we can set up our completing the square. What number goes in the box? Okay. Y squared minus 2y plus 1 factors to be what? Y minus 1. Great. So we don't have an x, we've got a y, it's going to be y minus 1. The right side, negative x, what? Okay. Now we need to get x by itself instead of y by itself. We have a horizontal parabola. So this is going to take 2 steps. Minus 6, y minus 1 squared minus 6 equals negative x. How do I do that? So that's going to switch all our signs. We'll get negative y minus 1 squared plus 6 equals x. So now we've got it in vertex form. What's the h value or the x value of my vertex? And the y value? Not negative 1, just 1. 6, 1. So there's our vertex. We can go ahead and start by plotting that point. Axis of symmetry runs through that. What's the equation for the axis of symmetry? Not x equals 1. The 1 was right. It's not x anymore because we switched y equals 1. Yes, Bryce?
So you just put x and y, but the rules still stay the same.
Like to complete the square? Yeah, the rules stay the same. We just switched x and y. And so now we're using y squared and y to make a perfect square trinomial instead of x squared and x. All right, what direction are we going to open? How do we know? Not the negative 1. Well, technically that negative 1. The negative coefficient in front of the parentheses says we're going to open left. Opens to the left. All right, so now we can fill in some other points. So we can do a couple x and y's. Let's do some y values. If our axis of symmetry is at 1, what's another y value that we could use to find a point? Okay, y equals 0. So if we plug it in, we have negative 0 minus 1 squared plus 6. What's 0 minus 1? Negative 1 squared. Make it negative. Plus 6. So what's our ordered pair? 5, 0. So we'll plot that. 5, 0. What's our symmetry point going to be? 5, 2. Go ahead, 5. 5 and 2. 5, 2 will be our symmetry point. Okay. All right. What's another y value we can use? 1. So use 0, just keep going down. Negative 1 minus 1 squared plus 6. Negative 1 minus 1. squared. Make it negative. Plus 6. Okay, so what's our ordered pair? 2, -1. 2, -1. Plot that point, 2, -1. And what's our symmetry point going to be? Say again. 2, 3. And that's enough for us. That's enough points. Now, considering that our parabola opens to the left, what's the lowest value in our domain? Oh, and it goes all the way to what? All the way to 6. So our domain is negative infinity. And then what about our range? What's the lowest y value? Keeps going. What's our highest y value? Infinity. So don't try and rush it, because we are flipping a lot of stuff. So you need to think really carefully about what's x and what's y, what's it supposed to look. Your time on it, all right? It'll get better the more that you do it, but you need to take it slow and really think about each step, starting with the vertex, identify the axis of symmetry, kind of plot the points one at a time, and use that symmetry in order to get your additional points. This slide here just kind of covers the general features of our parabolas with the equations. Our vertical parabolas, the vertical axis, okay, those are going to be our x squared equations. All right. We also have another one that we're going to see more is truly actually vertex form. All right, yeah, so we've got x minus h squared equals, instead of a, we use 4p, and we have y minus k. So that's a more geometric definition with vertex form, and p is a different variable that we use instead of a, and it gives us the focal length. It's a special feature of the quadratic, which also tells us how wide the quadratic is going to be. Okay? A does the same thing, but just with a different value, and we're going to explore more of that tomorrow when we look at focus and directrix. The horizontal axis okay, same idea, but we're switching x and y and h and k. So we'll have y minus k squared equals 4p x minus h. Okay, and I'm going to provide these formulas as a reference. So you don't need to memorize them, but you need to make sure you can understand the difference between the vertical axis, the horizontal axis, the x and y, the h. So that'll be provided, but you just need to make sure that you can read and understand the formula. Vertex is always h and k, no matter which parabola we have, it's h comma k. Then our leading coefficient is either going to open up on the vertical or right on the horizontal. If our leading coefficient is negative, we go down on the vertical or left on the horizontal. And I mentioned it before, these are functions, meaning they pass the vertical line test, but the bottom two are not functions. They would fail the vertical line test. So they are relations, but they're not functions. Any other questions, comments, concerns, quick amendments? Your homework is over multiple days. With what we've covered here, you should be able to do questions 1 through 6. Okay? Questions 1 through 6 on the homework tonight, and then with tomorrow's lesson, when we finish the chapter 10 content, you'll be able to finish 7 through 12. Don't wait till the last minute. Start the homework tonight, okay? Because tomorrow's is going to be a little more time consuming. So you're going to want to knock out the first 6 today, and then we'll build on that tomorrow.